Okay, this video is the last one for the modeling with exponential and power functions lab for my pre-calculus class. And I wanted to tell you that there's a negative sign here, and I want you to change both negative signs to positive signs. So that's a typo in my spot. So these are just positive numbers, okay? So the first number I have is 1/5, 25. And the second number or point I have is 2, 140. So we're going to go through what we did before. We're going to do the exponential functions, find a function that models those 2 points, as well as the power functions. So let's get started. So I have 25. That's remember, my x and y equals a, b, which our b is going to be, we don't know yet. Let's try that again. AB to the 1/5, because that's my x and my y. It's a ratio, so we're going to divide. I'm going to do 1/40 equals AB squared. Then when I go through, those will cancel out. So I end up getting, this comes out to be 1,000, so that's nice, okay, equals B. And when I subtract these two, 1/5 minus 2, I'm going to get -9/5 because I'm dividing. And then I'm going to raise both sides to the -5/9 because I have to figure out what B is. When I do, I get B to be 0.021549. So now I know y equals a 0.021549 to the x. And we're just going to plug in one of the points. So I used 1/5, 25. So 25 goes here, because I need to know what a is, 0.021549 raised to the 1/5. And to solve for a, this is hooked to that by multiplication, so I'm going to divide 25 by 0.021549 raised to the 1/5. So a, and I'm going to round it a bit to 53.86. So my formula comes out to be 53.86.021544 raised to the x. Not pretty at all. Hopefully the power function's a little prettier. So that's what we get when we do a exponential function. The power function, we're going to start out the same. I'm going to do 25 equals k. My x is down low, so that's going to be 1/5 raised to the p. Divide. And then what we're going to do here, again, is we're going to put the other point, 140 k x raised to the p. And thanks for playing. Again, this still comes out to be 1,000 when you divide that out, equals 1/5 divided by 2. So this is a little bit different. You're not subtracting. So that's 1/10 raised to the p. And now, you guessed it, the only way to find the power is the natural log both sides. So I have natural log of 1,000 equals p natural log of 1/10. The p is hooked to the natural log of 1/10 by multiplication, so I'm going to divide. So p is going to be the natural log of 1,000 divided by the natural log of 1/10. So that comes out to be a -3. So far I have, I figured out the power. So I have y equals k, whoops, let's try the equal sign here. Y equals k x to the -3. So now we have to find the constant. So all I did was plug in the point 1/5 25 in there. So 25 equals k 1/5 to the -3. They're hooked to the k by multiplication, so I'm going to divide 25 by 1/5 to the -3. And when I do, I get k comes out to be 1/5. All right, so this actually comes out to be nice, a nice little one. It looks a little bit nicer than there. Y equals 1/5 x to the -3. And that is our formula, and that's the last one on this. So I just want to make sure that you guys can, it's kind of a review for the exponential. And I know it's not pretty, but then you can do a power function very similar using logs and using a couple different algebraic things, and you can come up with your power formula. So I hope this helped.